Hello, ladies. So I am going to continue on from what we were talking about in class on the method of partial fractions. And I wanted to start, so I gave you the repeated linear factors case, and we're going to do an example of that in a minute. Yeah, I have one. But first, notice in the homework bonus I talked about when is a rational function not proper, or what does it mean for it to be proper and not proper. And so this is actually the formal definition of the partial fraction decomposition process for non-linear, non-repeating factors. And so if you want, you can pause the video, write this down, and then play it again. Okay, so suppose you have two polynomials, p of x over q of x, and it's proper, and q of x is a product of distinct linear factors. Okay, so we have something like this. Then the p of d equals, and we use a, b, c, and I would keep what we're using in class because of the subscripts can sometimes get in your way. But the reason why they're doing subscripts is because we don't know how many terms we're going to have, how many constants we're going to have in the numerator, but you won't ever go up to z, so we don't have to worry about going above the alphabet. Okay? But this is what we did in class, and so where a1, a sub 2 are constants, so that's the general setup. So this is sort of the formal definition. That's why I wanted to look at just an example, because this can sometimes be intimidating. All right, again, you can pause the video and write this down. So a not proper example. And I asked you to define what it means for a polynomial or a rational function to not be proper. And that's when the degree of the numerator, which is p of x, is greater than or equal to the degree of p of x is greater than or equal to the degree of q of x. And so when we have that case, if we have that situation, we need to use long division. All right, so if you need to review long division, make sure purplemath.com is a really good website for algebra review. They have some, I think, pre-calc as well, but they have some really good algebra review. They go step by step. So if you need to review some algebra, purplemath.com is a really good website if you don't already know about it. This might be 2 videos because I don't want to go over 10 to 12 minutes in each video. So it might be 2 videos, but let's see. So we need to use long division to write p of x over q of x as g of x plus r of x over q of x. And that's going to be, g of x is just going to be a polynomial, and then the rational function, because we just do the method of partial fractions when we have rational functions, right? If we just have some polynomial here, some polynomial g of x or some function g of x, then we just can integrate that with the other integration properties we know. Okay, so let's evaluate this example here. And so we have the integral of x cubed plus 1 over x squared minus 4. And we're going to review long division quickly, and I'm going to set it up, but I want you to finish it and turn this in for extra credit. So turn this in when we get back on Wednesday. I'm not going to do the quiz on Moodle. I decided I don't have time to do that. So turn this in on Wednesday, and I might have some other questions that you might need to answer in the video that I want you to answer, and this will be worth the extra credit point and I'll tell you what part you need to finish. Okay, so here we can clearly see that our numerator is greater than our denominator, the degree. So the degree of the numerator is 3 and the degree of the denominator is 2. And so long division, I like to use zeros as placeholders because it just helps me keep focus on what I'm doing and how I'm lining up my long division, but you don't have to if you're good with it. So as a recap, let me erase this. Oh, I didn't really erase all that. Okay. All right. X. Okay. so as a recap for long division, you take the first term of your divisor and look at the first term of your dividend. And your thought is x squared times what will give me x cubed? Well, we should know that that's x, and you align the x where it should go, above in the dividend. And then you take this x here and multiply by each term here. Okay, so that will get in right underneath, so that'll give us x cubed plus 0x squared minus 4x. Then you subtract. This is called the division. This is what's known as the division algorithm. The x cubes go away, the x squareds go away, and that becomes a positive 4x, and then we bring down the 1. You stop, you know when your long division is complete when the degree here is less than, not equal to. If it's equal to, that means you can do the long division again. But when the degree is less than the degree of your divisor. Okay, so this right here is our remainder. And so when we write up, when we rewrite this PFD, it's going to look like x cubed plus 1 over x squared minus 4 equals x plus 4x plus 1 over x squared minus 4. Okay. Now we're only doing the PFD here. However, when we set up our so in your final answer, so x cubed plus 1, you always go back. I like to go back to the original integral. This will equal the integral of x plus, well, actually, I'll do it like this. X dx plus the integral of 4x plus 1 over x squared minus 4 dx. And this is where we need to find, we need to do PFD. Okay. And I'm going to leave that for you to do in class, but we can set it up together. We'll set it up together. So step 1, remember, in the steps, step 1 is to make sure the denominator is factored, right? So x squared minus 4, it factors into x minus 2 and x plus 2. And I'm actually going to stop there. So I want you to finish solving the integral. So look in the notes again that we went over in class on Friday. And there were 4 steps that I talked about. You already know how to integrate that, so that's simple. But you have to find the PFD to that. So we just did step 1. So step 2, so goes to step 2. And let me say this. So remember, when you're doing the different steps, the integral symbol on the integration doesn't come into play until step 4, right? Step 2 is to set up the PFD, and then step 3 is to solve the PFD, and then step 4 is to integrate. So I'm going to leave that for you because I believe you guys can do this one. So if you finish this correctly, and this is either all right or all wrong, you'll get an extra credit point back, towards exam 1. Okay, so let's see if we can get through this one. Again, I will pause the video and write everything down and then come back. Okay, so now we're going to look at if we have repeated linear factors. Okay, and with repeated linear factors, oh, I'm sorry, I just realized that I would have got a half a point off for forgetting my dx. Okay, but here for repeated linear factors, each factor contributes the following sum of terms to the PFD. So all that means is you want to build up to whatever this repeated exponent at that number is. Okay, and so when you have repeated linear factors, the way to make sure, because like I said, this is step 2 because step 1 is already factored. But remember, I said if this isn't set up correctly, then I don't grade it anything else after that. So you have to make sure you set up your PFD correctly. Okay, and so we have here to set up this PFD, we have the left side, of course, and it equals a over x minus 1, because that's just that's not a repeating, so it's just a over x minus 1. And then we have a repeated factor of x plus 2. So then it would be b over x plus 2 plus c over x plus 2 squared. Okay. And that's the setup. So again, this is very important to make sure you understand if it's repeated. So if I had, oh, here's my second question. I don't like that color's too bright. So I don't know if that's any better. Question, what would the setup for the PFD look like for, let's say if we had 2x plus 7 over x times x plus 2 cubed times x plus 1 squared. So I don't want you to just solve, but what would, if you have the integral? Okay, so what would the setup for the PFD look like? So I'm asking, what would this look like? So think about how many constants would you need, and that'll be worth another extra credit point on the exam. Again, it's either all right or it's either all right to get the credit, no partial credit for these extra credit points that I'm handing out. And again, this will be due at the beginning of class on Wednesday. Okay. So what would that setup look like? So think about that. But in the meantime, we're going to get back to this and solve it. Okay, so we need to solve this. The first thing we do is clear fractions. Now, I did it in your notes, but I'm not going to show the step that I showed in the notes. I'm just going straight to simplifying. And so that would be, I want to make sure I might need a little more room. So 3x minus 9 equals a times x plus 2 squared plus b times x minus 1 times x plus 2 plus c times x minus 1. And if you need to, pause the video to make sure you understand how I got that, because like I said, I'm not including that middle step because that's algebra that, again, really, if you know you're not strong at algebra, just do some algebra review with simplifying and factoring. Okay, so now we have this, and now we have to, the process is finding our zeros. Now I'm also going to show you how to find the solution using the other method. So there are only 2 methods. Some of you on the homework bonus put 4, but there are only 2 methods in terms of solving for your constants. And so we're going to do the method that we did in class, which is looking at the zeros. Here we only have 2 zeros, right? So x equals -2 and 1 because of that repeated factor. Okay, so let's see what happens. All right, so when x equals -2, and I might have to stop this video because I don't want to go over 15 minutes, so I might have to stop this. But when x equals -2, the left-hand side, that's going to be 3 times -2, which is -6 minus 9. It's going to be -15 equals, well, -2 will get rid of those 2. And we'll be left with c times -3, I believe. And so that means c equals 5. If my math is correct, c should equal 5. And then when x is 1, we're going to have -6 equaling 9a, and so that means a is -2/3. And I skipped some steps there, so I want you to stop the video and check, and then I'll be back in the next video to finish the problem.